All right, welcome. We're gonna continue working with this case. First off, we're gonna design some components that we need. For example, some threaded um, brass. We're doing this brass threaded insert. That's the word. And these things are really useful for when you're 3D printing something and you just want to embed something that is threaded, so you can use actual bolts. This is really useful. We have some of these, and I already took some measurements. Well, I got some help doing that. So, what's this, by the way? Can I delete it? I guess it's not needed. Um, oh, now I see what it is. All right, maybe that was needed. So planar, yup, with you. There we go. Awesome. And then it said no. There we go. Awesome. We can actually rename them, you know? I can say this like closing or joining parts. Could be one. What is this? Yeah, like each one could have a name if needed, but I mean, not needed by now. Okay, so let's start. I get distracted. Create part studio. We're gonna make a bolt, the bolt that we need. I'm gonna use a revolution. We're using this M3 by 16, M3 by 16 millimeter Allen. We're using more like this one, pretty much. That's the one we're using. I already have some measurements, and I'm gonna use the measurements. We're gonna use. You can do it several ways. I'm gonna teach maybe not so common way, but I think it's good to learn different methods. So for example, right now I'm drawing half of what it would be a bolt, half a section view of it. And so important here that you have to use the measurements in half. So for example, the head of it, the diameter is 5.37. So you can do 5.37 divided by 2, like that. This right here, this would be the complete measurement because it's not being divided. 3.2. This would be 15.6. I hope the measurements are right. Actually, I'm starting to doubt a bit. Uh-oh. I mean, it should be 16 because the name of the bolt is M3 by 16. So, just to make sure, I'm gonna take some measurements. Let's see. Yeah, should be 16. Let me check the other ones. 5.37, that's good. Okay, so this should be 3, and this should be 16. And this should also be, let me see, 2.93. Yeah, 2.93. 2.96. Okay, good. And this would be divided by 2. There we go. Now I'm going to make this line. No, I don't think that's right. Yeah, so I'm gonna say, hey, you know what? Make a revolution. No, sorry, my bad. Make a revolution, this whole thing, which is the revolve axis, and you pick a line, and there you go. It's revolving, yeah, 360 degrees. I'm gonna rename this part M3 by 16 Allen bolt. Great. And now, actually, I can start using them here. Well, I'm gonna finish all the parts. Create Part Studio, rename. Let me look for the name of the one we're using right now. M36 by 5. M36 by 5. All right. So this would be M3 by 6 by 5. Threaded insert. This is pretty simple. I'm gonna make it in a different way. I'm gonna sketch plane. I'm gonna do top. I'm gonna make a circle. This is a 5. Yep, 5. And it's 6. Good job. Ouch. All right. I'm gonna extrude. Extrude by 6. There we go. And that's that. I mean, you could actually make a little hole. Yeah, why not? I'm gonna modify this. I'm gonna make. We don't actually need it for our purposes, but you know, whatever. B dimension 3. There we go. And now you have that. All right. Now, can you? No, you have to have them there. All right. So here in the assembly, this part I'm going to hide it, and then, well, actually here I'm missing some holes actually. 6 was it? Let me check. I need to remember. This part, I'm gonna hide it, and I'm gonna measure from this plane up to this plane, and I'm gonna measure the distance. It's 6 millimeters. All right. So if I put a bolt here that is M3 by 16, 6 of those 16 millimeters are gonna be consumed here. The other 10 would be consumed in the other part. So I'm gonna do like a hole of 12, if that makes sense. Yep. So that's what I'm gonna do. A 12 millimeter deep hole. And now I'm gonna do it here. Now my threaded insert is 5 millimeters. I think I'm gonna do a 4.8 hole. 4.8 hole, or maybe a 5, or 4.9. Just a little bit small so that I can melt it in. Let's see if there's something online. Insert threaded brass insert into there. I know people do this. I'm gonna check 3D printed parts. Oh, all right. You know what? I'm going to research a bit, and I'll be right back. Okay, so they don't specify, but I learned a lot. So you know what? I'm gonna do 4.8. Yeah, I think 4.8 would work well, and we can modify later. But yeah, it should be a bit smaller than the diameter of the inserts. So let's do it. I'm gonna make it. I'm gonna edit in context. From top, I'm gonna make a drawing here. New sketch. I'm going to. Here's the center. according to, based on the concentricity of this radii. So yeah, now I'm gonna make a hole, which is gonna be 4 point, I say, let's do 4.8. Also, something you should do is make you use a lot of wall layers. So yeah, when you print, that's some of the parameters for printing. Anyway, I'm getting distracted here. I'm gonna make 2 lines, one from here to here, one from here to here. I'll select these, mirror. Well, then I'm gonna select this and this. I'm gonna say mirror, and then here from this one, mirror here. Oh, sorry. Okay, let's go again. Mirror, select the mirror line, select entities. There we go. And now I can cut, remove 12. There we go. You know what? I don't like it. Here's the issue, because yeah, that's an issue. All right. We should have 2 different diameters, yeah. All right. Yeah, like this should only be as deep as our threaded insert, so it should be 6. And then I should do another hole a bit smaller for just the remaining bolts. Although, you know what? I have some threaded insert that are longer. I have some that are 10. Precisely what we need. 10. You know what? Yeah, that's easier. I'm just gonna use those. Because 10 is what we like. Yeah, let's use the 10 ones. Or we can just use a shorter bolt, because we M3 by 16. Why don't we just say M3 by 12? Yeah, I like that better. So that's 6, and here I'm gonna rename this, and I'm gonna use a 12, and then here in the sketch I'm gonna change 16 by 12, and you're gonna have a 6 and 6. Yeah, that's way easier. All right, cool. And these last, like, extrusion should be only 6. Yeah, awesome. Great. It should be precise. All right. Why not? Actually, you know what? I'm gonna go a bit extra just in case. I'm gonna do 7. And while I'm inserting it, I'm just gonna make sure it remains flush. Or should we go really precise? I think we should go precise. Maybe, yeah, let's do 6. I'm sorry. Yeah, that should work. That should work. All right, so that's done. Now in the assembly, pretty much what we're gonna do is we're gonna insert our threaded insert 1, 2, 3, 4, and then 1, 2. Oh, wait. I'm pretty sure there's a way of... Okay, you know what? I'm not gonna have that much time to experiment. So, oh, yikes. All right, insert 1, 2, 3, 4. I want to try something. I'm gonna use the cylindrical mate. I'm gonna select this outer face. and then here, and then planar. No, that's parallel. Planar, here and here. There we go. Now something I want to do is select this part and make a pattern direction, this direction, the other side, and I can change this number 20. Oh, those are the instances. I just need 2. The distance is here. I think I can select it and scroll with the mouse, and I can go like this. Something I can do before doing that, I can measure from hole to hole 87. All right, so I can, again, linear pattern, no. Linear pattern, this part, direction, this direction, no, sorry. Direction, this direction, and we replace this with 87. There we go. You know what? I can do a second direction. Here. Look at that! Woohoo! Oh, I didn't took the measurement. I don't remember. Okay, so sorry, I'm gonna have to cancel this. So it's 87 and 67. 87, 67. I can remember that. All right, linear pattern. We select this part, direction, this direction, the other side, 87, second direction, 67. There we go. Oh, it's so easy. Oh, 67. Awesome. Now, same thing, insert. Let's make this one visible again. Let's bring one of these bolts. Oh, yikes. There we go. Awesome. Now, linear pattern. Well, no. First off, let's make these in place. There we go. And now something we have to do is say, hey, you know what? I want this. Oh, come on. Haven't even done anything. All right, come again. I'm gonna select planar, this face, this face. There we go. Awesome. Really? Yeah, that's good. Yeah. And then actually we see it like no. Is that the ball? Oh, it's going farther. Can I edit in context? It should be 6 and 6. Huh. That's weird. Oh, switch to M2. Yeah, switch to M12. Yeah. Wait, what? Oh, I have to. I didn't confirm that operation. That's why in the assembly, there you go. It's not going farther. Awesome. Good. Now let's go back to shaded. Let's select it, and same thing. Let's do a, oh, you know what we should do? We should make this piece before the linear pattern, and in the linear pattern, we can edit it and we can say, yeah, you know what other piece I want here? I want this one. So now I'm gonna have all the bolts and all the threads and in the pattern. Look. Awesome. So you have the original, and then the pattern. Nice. Good job. Now, we should, okay, so that's the whole assembly actually. That's the whole assembly to make this work. Oh, you know what I'm missing? Let's hide this one. We need the things that are gonna support this. So, oh, yikes! All right, let's make this happen. Here, I'm going to edit in context. This is gonna be really good because take this part, edit in context. Here it is. And now I'm gonna make a new sketch in this face. And I'm gonna say, can I project this circle I needed, this circle I needed, this circle I needed, and this circle I needed. And I need it precisely for making, I also need threaded inserts actually. So actually it should be mirrored. So in theory, I should be able to only do one. So only with one, because I remember I centered this board. So only with one. This original circle is just gonna be a reference. So I'm gonna use it as construction line. And then the one that I really care about, I just gotta check something. This PCB board would only receive from me M2 bolts, and I have M2 by 8. I think we should use the smallest ones. M2 by 8. Yep. M2 by 8. All right. Give me 1 second now. All right, I figured it out. We got new components. We got this. Let's go for it. So one new component. Actually, can I make folders? I should be able to make folders. Let's make a new folder. And the folder is gonna be a bolts and inserts. That should be one. And like that's one. I just don't want everything here. So let's rename these two M2 by 6 by 3.5. And this is pretty much the measurements that threaded insert. What time is it? Okay, good. We got time. All right, so let's do it. Sketch, top, circle, circle, 3.5? No. No, it should be like 2. And the outside would be 3.5. Yeah. 3.5. And should be around 6. Righty. And then we have another one inside this folder. Rename. This is gonna be an M2 by 8 Allen bolt. Actually, you know what I should do? Should delete this one. I should duplicate this one. I should rename it as M2 by 8 Allen bolt. I'm going to this thing. Oh, come on. Front. 3.4. So it should be 3.4 divided by 2. And then 1.87 divided by 2, and then it should be 8, and one point 3. And there's a bit of a curve, so whoop, boop, just to make it more real. Ta-da! All right, so many things. Let's get out here. Actually, I'm feeling tempted to do another folder called 3D printed parts, and in this one I'm gonna bring case top and case bottom. This assembly is gonna be called blinkers assembly. I'm gonna make a new folder called electronics. I have the battery and the PCB. All right, that's, oh my God, look at the organization. All right, good. So now let's go back to here, edit in context. There we were. And now we know that our threaded insert is 3.5. How much was it, sorry? It's a 3.4. So we should do a 3.2 maybe. So I'm taking like, because this one I did like 537. No, that's not the one I want to know. I want to know the other one. This one. No. I want to measure how big did I did this hole? 4.8, because it was 5 and I took 0.2 millimeters. So in this case, it's 3.4, so I can do 3.2. All right. So I think this one should be 3.2, and then this one should be maybe 6. I mean, there's not like we just need enough space, you know, like maybe 7. Yeah, it should be thick. I think 7 is good. Now, from the top, I can draw 2 lines. These 2 lines are gonna be mirror, and then I select again this one and this one, this one and this one, mirror here. There we go. And those should match the actually, let's go see. So let's get out of here. I'm going to the assembly, select here, edit in context, context 1. I don't even know what a context 1 is. Oh, look at that. And they should match the center of our board. They do. Good. Now, this sketch, we can extrude it, but for, I think it's gonna end up being, okay, sorry, I'm gonna get out of here, and I need to know what the distance between this face and this line is. 30.23. So I think 30 is good. 30 is good. So this is sketch, extrude 30. Oh, yikes. No. This is sketch, edit, extrude. There we go. 30. Extrude, solid, add, merge. Yeah. There we go. I don't like these things. They're pretty like, what's the word? Like, flimsy. So maybe I should add like a nerve. What would happen if I just add the nerve like that? Like, sketch profile. Oh, I need a sketch profile for a rib. Yeah, no. I think if I just add it to this, that would make it easier. If I just add it to the sides. But then I would leave, you know what? I would just join it to the whole thing. Because I think this might break. So yeah, you know what? I'm gonna edit this drawing. And pretty much what I would do is I would go from here to here, here to here, here, and maybe here to here. I'm making my life too complicated. No, I have an idea. Here to here, here to here, here to here, here to here. And then this line should be horizontal, this line should be vertical. here to midpoint. This line should be sorry. This line should be construction. This line and this line should be perpendicular. And then actually that's pretty good, but I mean things might move, yeah. So maybe I should just add some dimensions to here, like 6, like 2.8, and then I should say that this and this should be the same. I should say that I should make a line from here to here and from here to here. These two lines should be construction. This one should be horizontal. This one should be vertical. Everything moved. Something got messed up. Why is that happening? Actually, you know what? I'm making my life too complicated. Maybe I should delete this one and just make sure this one is vertical. This one is horizontal. And then this one should go here. This one should go here. I think that's pretty much good, actually. I mean, all drawings should be fully constrained. I don't know why is this not. Why don't I just put a. And then I say, hey, this and this should be equal. There we go. And now this is moving, but how about I just make it 45 degrees? Well, 135. There we go. Now I can just use the scissors and delete this part. And now I should delete all this, select all this except this one and this one and this one, and then say, hey, can you mirror here? There we go. And then again select this whole thing except you and you. Okay, and then mirror. There we go. And then again, well, the extrusion is already there. I think that's better. That won't break. There's also less travel. It's gonna be printer fast. Even if it's how do you say it? Even if it's more volume, it's pretty much less printing time. Actually, not sure, but anyways, more strong. Like it's not stronger. Yeah. All right. We're about to finish, so I'm just gonna continue. Go to assembly. This part I'm gonna hide it, and then I'm gonna insert. Well, first off, I'm gonna check the distance between the things. So I'm gonna insert one thread insert and one M2. And now I'm gonna measure. Is there a shortcut for this? No. here to here, 75, 35. Can you remember that? I can't, so I'm gonna write it down. Where are my post-it notes? 75, 35, and now I'm gonna measure from here to here, 55, 35. All right. I'm gonna make this guy connect with this guy. Oh, there's an issue though. I shouldn't let the whole thing go down. Hmm. 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 All right, so that's wrong. We shouldn't let the whole hole go all the way down. So what we should do is the following. We should get into this one. Edit in context. Top. This sketch. Edit is 3.2. Let's remember that. And let's make it construction. We're gonna do it in a different operation. All those things. Let's make it construction. So now that is construction, it won't appear. As you can see, there's not there anymore. Then in here, I'm gonna make a new sketch from the top. I can project. I think that's, or yeah, I can. No, I don't need to project actually. I can just make a circle based on the radius because they were concentric. On the fillet, sorry, 3.2. I can make 2 lines like we usually do. These 2 lines can be construction. Now this, oh sorry, you and you, mirror, and then this whole thing, mirror with this line. There we go. Extrude, remove, and it's M2 by 1. M2 by 6, is it? Yeah, 6. There we go. Way better. All right, now I can say, hey, cylindrical from here to here. Got it. Planar from here to here. Got it. And then where's the board? I'm thinking of getting like plastic. I have some plastic washers, so maybe it would be nice to have some plastic washers in between. I'm not gonna do it for now. I think it's gonna take me too much time, and it's something that it can be solved easily. But in between the PCB board and these things should be, I think there should be a plastic washers to prevent, I don't know, electricity flowing through them. So let me see the board again. There it is. Now I can do cylindrical here and here, and then where the board is, Oh, yeah. Planner from here. Oh, wait, where's the board? Why it appears? Planner from here to here. There it is. And now, what I can say is these two parts. Okay. These two parts, I can do a linear pattern. The direction can be this one, other way, and it was 75-35. Second direction, direction being this one, and it can be 55-35. There we go. There it is. Nice. Great. All right. We're getting there. We're getting there. Great job so far. All right. I'll see you in the next video.